whole number. The first number written here is 10,000. That is 10 of 1,000. One is, we have 3 zeros. 3 zeros represent 1,000. So we have 10,000. So if you're able to see, you see that this is 100, 100 of thousands. This is 100,000. The 3 zeros, 000 is 00. So we have, anytime we have 6 zeros, so it's million. So, but now we have 1 million. You can have 2 million, 1, 2, 3, 0, 0, 0. So this is 2 million. So this is how we represent. So let's have an example. The example says that write in words. Let's see it. Write 4, 3, 4, 5, 9, 1, 9. So if you want to write this in words, it will be equal to, you're able to see that we have one. We want to count the 0. 1, 2, 3. 3 0. 1, 2, 3. We have 6 0. So the moment we have the 6 0, it means we have 4 million. 4 million. So we have 4 million 300 and 45,000 919 919. So this is this example. So we have 4,345,919. So that is. So let's also have another example. So let's explain this example too. Write in words. The first one. So if you are to write this thing, this value in words is, we have 4,000, and it's 4,619. So the second one, which is the B part, so let's write this in words. So if we want to write this, we have 7 million. As I've said earlier, let's count the 0 from 2. We have 1, 2, 3, 1, 2, 3. So we have 6 0. So the 7 of 6 0 will give you 7 million. 7 million. Put a comma. 7 million. 7,000. You're able to see that there is no value here. 7,002. So this is expansions of this. So that is how we expand. So we want to count number up to 1 billion. The first number you see here, when you count it, we have 6 zeros. 1, 2, 3, 4, 5, 6. So the 6 0 here, it is 1 million. We have 6 0 again here. 1, 2, 3, 4, 5, 6. So the 10 of these 1 million, we now call it 10 million. You see the 6 0 again. You now have 100 of this 6 0. We call 100 million. Mean that 100 million. So now we have 0, 0, 0. So the moment we now have 1,000 of 1 million, that's 1,000 million, we call it 1 billion. So if you want to write out 1 billion, 1 billion will give you 9 0. So let's write this in a normal numeral. He said, write the following in numeral: 1,242,564. So he said 1,242,000. Still have another 30. 564. He said 564. So this is how it looks like. So this is just the value: 1,242,564. So let's see the second example. He said 1,289,215,316. So let's write this one out. It will be 1 million. It's equal to 1,789,215,316. So that's one. This is 1,789,215,316. So that is how it looks like. That is how we pronounce it. So let's also go to the next example. So counting in trillion. As I've said earlier, this is 9 zeros, and 9 zeros give us 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 after the 9 give us 1 billion. Let's put 0, that is 10. We have 10 billion. Let's put 100 here. We have 100 billion. So the 1,000s of a billion, it is what we call 1 trillion. So again, the 1,000s of a billion, it is what we call 1 trillion. So let's have an example for this. So let's write this in words. So therefore, he said, write this in words: 9 trillion 312 billion 215 million 407,116. So let's write it out. He said 9 trillion 312 12 billion 215 million 7,116. So that is the pronunciation for the numeral. So you do this as class work before we go to the applications of large number to real life situation. So for the class that we have able to have done before this place, you will write this solution, this classwork to the comment section. You will write it in words. In the YouTube comment section, you will write it. So I will vet. This is how I will know that you passed through this class. So the A 5000216, B 9312400 407 C 8612152, D 1682. So you will do this. You write it before you go to the next stage of this class. Now, what to talk is about the applications of large number to real life situation. How do we use this large number in our real life situation? For example, maybe let's have example 1 under the real life situation. Somebody said 100 of thousands to multiply 1 of million. So 100 of thousands to multiply 1 million. So let's a solution pattern. So if you're able to see, you see that 100 of 1,000 can be written as 10 raised to the power 5, because by the time we count the zeros, you realize that it is 5 zeros. 1, 2, 3, 4, 5. 1 million, as I've said earlier, 1 million. If you're able to see 1 million, we have 6 zeros. So therefore, in writing it out, 100 of thousands to multiply 1 million, it will be as you said, 10 raised to the power 5 times 10 raised to the power 6. So it will be 10 raised to the power 5 plus 6, which is equal to 10 raised to the power 11. So that is the value. Also, it's also continuing to have another example. Let's have example 2 in real life situation. Somebody says that half of a million, half million to multiply 1/4 of million times 1/5 of a million. So now, what you're going to do is you'll be writing it out one by one. What is the meaning of half of a million? Half of million. Half of a million is 500,000 in a practical sense of life. 1/4 of a million That is when you divide 1 million into 4, you will have 250,000. When you divide 1 million into 5, 1/5 of 1 million will give you 200,000. So now, and the question says we should multiply all. We should multiply the half, therefore, the half of million to multiply 1/4 of million to multiply 1/5 of a million will now be equal to 500,000 to multiply 250,000 to multiply 200,000. So now, in multiplying this, let's put some analysis up. Let's count the 0. Let's count 1, 2, 3, 4, 5. Let's leave the 2. 3, 4, 5, 6, 7, 8, 9, 10, 11. So meaning that we have 5 times 25 times 2 times 10 raised to the power 11. That is 10 raised to the power 11. Now, this is 5 times 25 is 50. So 50. Now 50 times 5, it will give you, that is 250. Let's count the 0 again. 1, we have, that is the first one is 200,000. 250, 500,000. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sorry, it's 14. So it's 14. So now that is 10 to the power 14. So times 10 to the power 14. So what you do here is that you can now say is 2.5 times 10 to the power 16, because you remove 20 from here, put it around here. So it will now be 2.5 times 10 raised to the power 16. So this one is real life applications of the whole number. How do we use it? So let's also have another example. As we are doing more example, we make you to understand it better. Let's have example 3. Somebody says that add 0.6 million, 0.3 million, and 1.8 million. So let's have solution. So let's be writing it out one by one to know the meaning of 0.6 million, 0.3 million, 1.8 million. How does, in real lifestyle, you just see sometimes when you are hearing newspaper, they will say that federal government are able to release 0.6 million to in a budget. What is the meaning of 0.6 million? What is the meaning of 0.3 million? And what is the meaning of 1.8 million? So the meaning of 0.6 million is 0.6 million is when you just say that 6/10 of a million, that is 600,000. That's what. So anytime we have 600,000 is 0.6 million. For example, we have 0.3 million. When you decide not to call it 300,000, you said 0.3 million. This is 300,000. So we also have what to call 1.8 million. The 1.8 million, it means 1,800,000. 1,800,000. So in adding these together, if you are to add, let me just add it from here. Let me write this. It is here I only heard the mistake, so let me write the 1 million. So now, so it will be easy to add now. Let's put the 1 here. This is 800,000. So let's add everything together. So if we are to add all this together, let's see. Now, good. So a 0 we add together, all the 3 zeros will be here again. 1, 2. So good. It now remain 3 plus 6. 3 plus 6 is 9. 9 plus 8 will give you 17. So you write 7, you keep 1. So 1 plus 1 will give you 2. So let's count again. If you're able to see, it will now be 1, 2, 3. That is thousands. 1, 2, 3. Any moment from now, I see million. So mean that we have 2 million. 2 million 700,000. So that is how it looks like. So this is, we call it a real life, how we use whole number in real life. This is just the one part of the applications of real number in a real life style. So we also proceed to another very reasonable example that will also give us how does it look like. So let's also have another example. We are an example 3. So let's go to example 4. There's a question said that how many minutes are in. So want to know the minutes are Roman figure 1, 1 year. 1 year. The Roman figure 2, 2 years. So let's take a year as 365 days. So let's now see how we are going to see how many minutes we can be able to see in a year. So we want to see the minutes in a year. So now, as he has been given from the notes here that 1 year is equal to 365 days. 1 year is 365 days. So a year is 365 days. And we know that number of hours in a year. So let's now find number of hours in a year. Number of hours in a year will give you the 365 days. A day is 24 hours. A day is 24 hours, you know. So now the numbers of minutes. Numbers the number of minutes. Numbers of minutes will now be the 365 days, because we have 24 hours and 1 hour is 60 minutes. So by the time we press calculator to multiply all 365 times 24, you also use your calculator to cross check. 365 multiply 24 times 60 will give you 525,600 minutes. So we're able to see 525,600 minutes in 1 year. So let's also go further to calculate the minutes we are going to get in 2 years. So the B part, the Roman figure 2, is said in 2 years. We know that the 2 years will now be, since we're able to get 365 days means 24, 60. So this one is a year times 2, all in minutes. So therefore, by the time we press our calculator, we know that, but you also try to cross-check by pressing the calculator. So the final answer is 1,051,200. So let's we said 1,051,200 minutes are the minutes in a year. That's just all, because this is, we have 365 days. Days is 24 hours and 1 hour is 60 minutes. So that is how it is. So we can still also have a reasonable example that can still give us how we see a large number. So let's also have another example, like maybe let's have the next example. I don't know the example we are, example 4. So let's have example 5. He said, how many seconds are in 2 years? So I want you to note something. I want you to understand a fact that from our solution, the fact is this, that 60 minutes is one that gives us 1 hour. Now, but 1 minute on its own, it will give us 60 seconds. This is where we are going to seconds. Now, we are able to get the for 2 years, we are able to get 1,051,200 minutes. So, in finding the value for 2 years in seconds, it will just be, since 1 minute will be 1,051,200. Instead of writing the minutes, you just write times 60 seconds. So by writing it out, the final value will now be 63,072,000 seconds. So that is the number of years that we are going to meet in 2 years. Numbers using index notation. So it's still continuing to this extent, that so because there's some certain stage when there's high number, so you need to put it in an index form to make it meaningful in pronunciation. Let's just say maybe something like 10 is equal to 1 times 10. Let's have like 20 can be written as 2 times 10. Let's have 100. 100 can be 1 times 100. Can be written as 1 times 10 times 10. What do you observe? The 10 comes in two forms. We have 10 square. We also have something like 30,000 can be written as 3 times 10, 100, that's in thousands. We have 3 times 10 times 10 times 10. So let's count the number of 10 that occur times 10. So if you're able to see that, you notice something that the 10 occurs in 1, 2, 3, 4. So the 10 occur in 4 places. So that is 3 times 10 raised to power 4. So let's for example, you have 2, 3, 7, 4. Now let's try to add it together to make it meaningful. This is 2,000. This is 2,000 plus 300 plus 70 plus 4. So the 2,000 is 2 times 1,000, if you're able to note very well. Now plus 3 times 100. Now plus 7 times 10 plus 4. So what we're just trying to do here is that we want to know the number of tens that occur. That is 2 times 10 in power of 3, because it occurs in 3 times. 1, 2, 3. 1 to 3 times. Plus. So we have plus 3 times 10 raised to power 2. Now, that is 10 raised to power 2 plus 7 times 10 raised to power, we can call it 1, but just put now plus 4. So where exactly we are going to is, we want to try to make everything to be in power of these 3. So if you want everything to be in power of these 3, meaning that, see, we have 2, it will be equal to 2 times 10 to the power 3. Now plus, recall that instead of writing 3 times, let's write 0.3. Let's write 0.3 times 10 to the power 3, if you're able to see. Plus, we have in the value of the 7, let's have 0.07. It can give you the same thing. 0.07 times 10 to the power 3. We also give you that. Now plus 0.004 times 10 to the power 3. So 10 to the power 3 is common. That's 2.374. So the final answer we give you 2.374 times 10 to the power 3. So that is how the index form looks like. So for example, let's have an example. For example, we said express 40, 1, 2, 3. We have zeros in index form. Now, if you have to write this in an index form, as I've explained earlier, the 40, 1, 2, 3, 1, 2, 3 will now be 4 times 10, 1, 2, 0, 0, 0, 0. So now, let's split it by 10 times 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 10. So let's count the number of tens that occur. 1, 2, 3, 4, 5, 6, 7. So if you're able to see the number of 10 that occur here is 7. So this value can also be written as 4 times 10 raised to power 4 times 10 raised to power 7. So that is how it looks like. So I want to explain a group digit. A group digit is sometimes when you have, if you write a number like this, 5, 2, 3, 5, 6. No, I don't want to give a space. 5, 6, 7, 2, 3, 1. You discover that it might be difficult to pronounce this value. So we now have tried to group digits. So ability to group according to where the digit forms. So that's what we call a group digit. So for example, if we want to write this number, we write it in this form, like 5, 2, 3. You give a space, write 5, 6, 7. We give another space, 2, 3, 1. So in pronouncing this, it can be written as in pronouncing this, sorry, to have 1 here. So let's put 1. So he said 1 billion 500, and let me write it better. Can write it in the form like he said 1 billion 523 million. He said 567,000 237. So this is how it looks like. So we also have what we call digits and words. Let's also explain this. He said digits and words. In digits and words, what is just true, as in, for example, maybe we have in Naira, we have 3.4 billion. We also have in Naira again, we have 0.65 million. Some maybe in news, or maybe there's a budget, we have 3.5 billion. So this is what we call digit and words. Sometimes we represent them together. So in pronouncing it at once, so to make the statement meaningful. So let's just try to expatiate this way. For example, let's have an example in this. We have an example. We have somebody said 3.5 billion. 3.5 billion will be in Naira, that is 3.5 times 1 billion. And 1 billion is 1,000 of 1 million. So that is just 1 billion. So by the time we multiply these together, you recall that this is a point. It will now change to, this will now be 3,500. Remain 3, remain this. So if you have to pronounce this, you discover that this is 3,500,000,000. So let's also have an example that's reason to it. 6.5 trillion. So 6.5 trillion, in a literary way, you know that it will be 6 trillion. It will be 6,500,000,000,000. So, but in writing it out mathematically, he said 6.5 to multiply 1 trillion. So 1 trillion will be, let me write it in where it will contain whole. So it will be 6.5 times 1 trillion. So and 1 trillion will give you 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So in overall, the value will now be 6 trillion 500 million. 1, 2, 3, 500 billion. So you're able to count now. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it means 6 trillion 500 billion. So that is just the value.